for example, one of the other amazing things about that paper is that they were able to, Angela and Megan were able to literally visualize waves of information passing across embryos. We have videos of where you can actually see, and in order to make it easier, what we did was exert a very specific event. So basically like a needle poke into one of the embryos, so that way you know exactly when it starts, right? And then you can actually see, using this calcium indicator fluorescent dye, you can actually see this wave of information passing through from the point of injury through the animal, and then to the next animal, and then to the next one. You can just watch these signals propagate. It's just absolutely striking. We're dealing here with fairly complex processes. So it's not a binary yes or no, right? It's not a binary, am I being attacked or aren't I? It's sort of, normally I would build a head of a certain shape and size, and now I'm unable to do that. And so passing information on how to build a tadpole head requires lots of information. And this is one of the big mysteries going forward, is how do you encode all that information in a single signaling molecule that's passed, right? Because it's not just the yes or no. You have to actually, I think, you have to actually encode considerable amount of information for the embryos to help each other. So whether that's happening through some sort of modulation of pulsing through the water, or it's got to be something other than just simple, like here's your ATP concentration and that's it. It's a single number. You're not going to encode head morphogenetic data in one number. And the other thing to mention is that these projects are also going to come together, because one of the things that I would really love to see is how this shakes out in the Anthrobot case. So one of the things that we will be doing in the future is looking to see, do the Anthrobots communicate with each other? Do they communicate with the other tissues that they find themselves in an environment with? What's how general is this? Because obviously it begins in the frog model, but of course, as Angela said earlier, ultimately you might want to basically fake it for biomedical purposes. So whatever signal is allowing tissues and organs to form properly, you would, in these high density groups, you would want to be able to induce that on demand in the patient. And so the next step leads through biological tissues, and especially Anthrobots, to see whether that kind of phenomenon is general and whether we can harness it for biomedicine.